Using a team of world-class engineers with decades of tunneling experience, the Delta Conveyance Design and Construction Authority, DCA, working at the direction of the Department of Water Resources, DWR, conceptually designed a tunnel that will be resilient to flood and earthquakes and operate mainly by gravity flow to deliver water to the Bay Area, San Joaquin Valley, Central California, and Southern California. The Delta Conveyance Project tunnel construction is expected to take place in a predominantly rural area at depths ranging from 100 to 130 feet below the ground surface to the top of the crown of the tunnel. Because current information shows Delta soils are mainly sand, silt, and clay, an earth pressure balanced tunnel boring machine, or TBM, is the most appropriate excavation method. The TBM uses a large rotating cutter head to excavate soil for construction of the tunnel. Precast concrete tunnel segments will be transported from the tunnel launch shafts to the TBM, which are then erected to form rings. As the TBM advances, additional rings are attached to form a continuous tunnel lining. These rings are sealed with gaskets to prevent water leaking into or out of the tunnel, thereby avoiding any adverse effects to local groundwater levels and also maintaining ground stability. Have there been tunneling projects with similar characteristics to the Delta Conveyance Project? Tunneling technology is constantly evolving and is widely and successfully used in projects both in California and around the world. It has increasingly become the preferred method for mitigating environmental impacts in large-scale projects such as the Delta Conveyance Project. The following tunnel projects share similar characteristics with the tunnels of the Delta Conveyance Project. Joint Water Pollution Control Plant Effluent Outfall Tunnel in Whittier, California. The new tunnel, ranging in depth from 50 to 450 feet, is currently being excavated using a single heading spanning approximately 7 miles in length. The TBM was launched from a shaft constructed with diaphragm walls, ensuring a watertight enclosure. The tunnel is being excavated within saturated soils and very weak rock formations, similar to the Delta Conveyance Project. HS2 Chiltern Tunnel in Buckinghamshire and Hertfordshire, England. The two tunnels will each be 10 miles long with an excavated diameter of approximately 32 feet, which is similar in diameter and tunnel drive distance to the Delta Conveyance Project. The vertical tunnel alignment will reach depths of up to 300 feet and will be excavated by two pressurized TBMs. These projects are situated in urban areas in close proximity to infrastructure, buildings, and urban activities. Tunneling operations for these construction projects has been ongoing for periods ranging from 5 to 36 months, and they have not resulted in any damage from tunneling vibrations, nor has any surface noise been detected from the TBMs. How will the tunnel be created? A maximum of 4 TBMs would simultaneously operate along various sections of the tunnel alignment. All tunneling activities would begin at the launch shafts at either Twin Cities or Lower Roberts Island. All materials and workers would enter and exit from the launch shafts, traveling the length of the constructed tunnel to the TBM where the tunnel excavation and lining construction would occur. The excavated soil, also referred to as reusable tunnel material, RTM, because of its anticipated potential for reuse, is transported from the TBM through the tunnel via conveyor belts to the launch shaft. Once at the launch shaft, the RTM is conveyed to the ground surface where it undergoes testing, drying, and is then stockpiled. How will TBM maintenance be performed during construction of the tunnel? TBMs are expected to advance approximately 2 miles per year, and some routine maintenance will be performed from within the tunnel. Like all machinery, TBMs require periodic maintenance to ensure continued acceptable performance. The project calls for maintenance shafts every 4 to 6 miles along the tunnel drive. As the TBM progresses, it passes through these maintenance shafts, allowing workers to perform maintenance activities such as cutter head inspection and repairs. The shafts are open at the surface and enable maintenance to be conducted in free air or non-pressurized atmosphere. The maintenance shafts are also used to ventilate the tunnels during construction and serve as emergency exits for workers in case an unforeseen emergency arises. At the conclusion of each tunnel drive, reception shafts will be used to remove TBMs. The machines will be disassembled and lifted to the ground surface in sections. How will the tunnel be maintained after construction? DCA has positioned a new pumping plant at the southern end of the tunnel to enable water to flow by gravity from the northern intake to new pumps near Bethany Reservoir. The tunnel and shafts, would be designed to be low-maintenance facilities. All of the shafts and associated access roads will remain after construction, and these shafts will be covered to prevent unauthorized access. After the initial inspection, tunnel inspections could occur using autonomous underwater vehicles or remotely operated vehicles without the need to dewater the tunnel. What are some of the advantages of tunneling? Tunnels have many advantages compared to surface conveyance infrastructure such as canals and aqueducts, including significantly fewer surface impacts, enhanced earthquake resilience, zero water loss due to evapotranspiration, unaffected by surface flooding as designed with elevated shaft pads and risers. For more information, follow us on social media and visit the website at dcdca.org.